Oh, all right. Good evening, everyone. Good evening. Good evening. Can we hear me? Can we please confirm that we can hear me? Okay. Good evening, Grace. All right. So let's give about 2 more minutes for more people to join in. So start 7:05 on the dot. So let's give just 2 more minutes for more Texas to join in. While we're waiting, how was our day? Hope your day went well. Oh, good to hear, Robert. Robert's mercy. Okay. So we only have 24 of us on the call right now. And okay, 20 now. Once it's 7:05, we would begin. All right. So it's 7:05 now. I believe we can get started. Can we all see my screen? Grace, thank you. My dear is well as well. Thank you very much for asking. This is breaking. Hey, let's tell network not to do that to us this evening. No? Is my voice still breaking? Is it better or still breaking? Let me know if to switch my network now. Oh, okay. All right. Give me a minute. Let me switch my network, and hopefully that would be better. Okay. Is it better now? Is my voice still breaking? Can we confirm if it's still breaking? It's better now. All right. Okay. Thank God. Let's hope that it remains that way. Okay. All right. So let's get started then. Okay. So good evening once again, everyone. Lushola. Okay, we'll come back to the quiz later. We'll come back to the quiz later, Lushola. Let's deal with today's one first, right? Okay, so can we remind me of what our able coach, Mr. Moses, taught us on Monday? What did we learn on Monday? What can you remember? I know some people are going to go and run to go and check their note. Oh. No one can remind us of what we learned on Monday. Hmm. So I'm not seeing answers fast. Does that mean we're going to go and do expo? Nobody. Ah, Mr. Moses. Come and see your people. This is how we're going to start today like this. Nobody can tell me what we learned last week. Or is it my network that is not allowing me to see the chats anymore? Hmm. I really think my network is terrible this evening. Apologies. Okay. So I'm hearing my network, my voice is breaking again. So uh Okay. All right. So apologies for this evening. No, please let me beg MTN to behave themselves. Okay. So can we all see my screen now? Can we hear me better? The last chat I'm seeing is that of Levina saying it's better now. Is that my network or have people been sending chats and I'm not seeing it? Okay. Okay, so I think I can see emojis. So I guess that means we can see me. All right. Um. So since the chat is not working for me at the moment, please our TAs kindly help monitor the chat in case there's any question for me, so I can follow through you guys. Thank you. Okay, so let's get started. All right. So today we're going to be looking into um you know, another AWS storage service. I know Mr. Moses on Monday taught us about S3, which is one of the AWS storage services, right? So this evening we're going to be looking at EBS and EFS. That's the Elastic Block Store and Elastic File System. That's what we're going to be looking at today. All right, so let's get right into it. We've already spent 15 minutes of our time fighting with network. Okay, so before we go deep into what EFS and EBS is, before we talk about what storage types are, I don't know how many of us have seen the attachment assignments that was uploaded to our LMS, where you are expected to read up some resources and then answer the questions that follow. If we've read those resources, this should not be strange to us, right? So, but just in case we've not read it, we'll start from there this evening, right? So, number one is talking about storage types. Basically, Mr. Moses already talked to us about what storage is and what cloud storage is. There are three different types, basic types, right? There's the file storage, there's block storage, and then there is object storage, right? So what is file storage, what is block storage, what is object storage? So I'm just going to give a brief overview. Please go and read up on the resources that are attached in our or that were sent to us through our LMS, right? So let's read up on those resources and answer the questions that follow. So file storage is basically storage where your data is stored in files in an hierarchical structure, right? In hierarchy. So you have like a folder, inside that folder you have a file, or you can have another subfolder and all of those things. So let's say for example, inside this particular folder here, right, you have the picture of a child, you have the a word document that is stating the attribute of that child, you have maybe a slide deck that is showing that is you are going to use to present and all of those things inside this folder. Now if I want to get to the image of the baby, I have to go through this folder, which means there has to be a path for me to go through, right? So file storage, they usually have directory, they have paths that you go through to get to the file you want to get to or the storage. So they are usually in an hierarchy kind of form. So the folder is the top level, right? And then the files, or if you have a folder and then you have a subfolder, you find out that this folder will come up, a subfolder will follow, then the files that are inside each of those subfolder basically. So that's what file storage is. Well, block storage is that the data is managed as blocks, unlike a file storage that the data is managed as files and folders in an hierarchical manner. This one is they are usually managed as blocks, like blocks of data. Say if you get read the resources that are we sent to you on LMS, you get some examples that will help you to better understand these things. But this is not our focus this night, so let's not dive deep into it. So just know that there are three types of storage. There's file storage, there's block storage, and then there's object storage. So for object storage, it means your data is stored right in a flat structure. There's no structure to it, there's no hierarchy to it. It is not in blocks. It's just you are putting the object inside. It can be different type of objects, right? It can be any type of object basically. And an example of object storage is like our S3. So I did a slide to do like a recap of what Mr. Moses taught us on Monday, and we talked about S3, right? And S3 is a cloud object storage service. Going back to the type of storage, so S3 is an object storage because you can take any kind of data, right? You can store anything, and the things you are storing in that's your buckets, for example, right? They are called objects. It can be in any format, in any shape, whatever it is. It can be a coding script that you're going to save there. It can be a picture, it can be a video, it can be in any format, basically. So S3 is an object storage service, right? And the key component of it are the buckets. Your buckets, like Mr. Moses explained on Monday, is where what is going to house your object. So your objects are the actual files, be it your images, your documents, your video, whatever it is that you are going to save, right? So each of the buckets is what is housing the object, right? Then you also have keys. Keys are the unique names that you attach to every file. Say, for example, you are saving a file and the name of the file is little group image, right? Maybe it was a picture that we all took, and then I want to save it, and I save it as little group image. So it is that unique name, that name I've used to save it is the key of that object. So if I'm looking for a particular object, I have to know, the name of that object because that is the key. And also is another component is that your data is stored in Mr. Moses taught us about the fact that it is scalable, right? It is easily scalable. So your data is stored around everywhere. It's spread across the world, basically in all the data centers that AWS has. S3 is one of AWS global resource, basically. So characteristics of S3 is that it is scalable, it is durable, and it is secure. So this is just a recap of what we did on Monday. So let's get into so I did a picture basically of this is an S3 bucket and all these things that you want to put inside, be it your picture, your video, a music, or a document. They are objects and they are all going into what the bucket. So your bucket is going to save or store or house each of these objects basically. So today's lecture is going to be focused on EBS and EFS. Again, EBS is Elastic Block Store. Elastic Block Store. I believe from the name, if I ask you which storage type does each of these ones belong to, you should be able to easily tell me which class, even from the name of the service, right? So is my voice still breaking? Can we hear me? I'm seeing Grace message that it's um network is not favorable. Is that general to everyone or okay? So anyway, so you can confirm that my own network is stable and everyone can hear me. Okay. All right. So you can hear me. All right. Let's move on then. Okay. Thank you very much, Mohammed. All right. So again, we're looking at Elastic Block Store, Elastic File System, and we'll be looking at their components, their characteristics, cost implications, and suitable use cases. We might not be doing a demo this evening, right? We might not be doing a demo. Most likely, we'll not be doing a demo. Yeah, so let's get into it. So, what is Elastic Block Store? So, again, like I said, the name has already given it away. So, it's a storage service that allows you to store data as blocks. So, which means that elastic block store fall under the category of a block storage service, right? I said at the beginning that we have three different storage types. We have file storage, we have block storage, and we have object storage. So, elastic block store service is under the block storage type, right? Is under that category. So it stores your data as blocks, and it is like attaching a hard drive to your computer. So basically, um your elastic block store is like your computer hard disk. It is usually attached to an EC2 instance, right? Elastic block store is usually attached to an EC2 instance as a storage disk. Remember, we we're talking about the component of EC2 instance. We talked about the RAM being a temporary memory and then the storage disk. So EBS is the storage disk for an EC2 instance. And since we said an EC2 instance is like your virtual computer, right? Is your virtual server, is your virtual computer. So an EBS is like your hard disk. The way you have hard disk in your computer system, that is the way EBS is to a virtual server, like your EC2 instance. And the use case for EBS is that it's used for running databases that are storing or for storing application data. So if I have an application that I have hosted on my EC2 instance, right? It is the EBS that is attached to it that is going to store all the application data. We're going to go into the component or the characteristics of it so that you understand why it's the one that store your application data, right? So example of it is when you launch an application on your computer, it will store either temporary or permanent data on the hard drive. Basically, if you have an hard drive, if your computer should crash right now, you can always remove the hard drive or the hard disk of your computer, of your laptop, and then you still find the things that you've stored on them there. It's still fine. You can put it into another, you can connect it to another laptop, basically. Why? Because it's a separate storage, it's not the RAM. If your laptop should crash, everything that is in the RAM is going to go with it. But your hard disk is still intact. So it's for a much more permanent storage of data for applications or for your computer, basically. So what are the characteristics of EBS? I hope when I say EBS now, we all understand what EBS is, right? So characteristics of EBS, number one is that it's a block level storage. I guess I've already explained that from beginning, right? So your data is stored in fixed size blocks, allowing for efficient data retrieval. So basically what that means is, say for example, you have an application that you have stored on your or you have hosted on your EC2 instance. Now, the information of that application is going to be broken down into a fixed size, like a block. It's going to break it into sizes of block, equal sizes of block, right? So when you want to retrieve a data of that application, you want to retrieve a data, it's easy for you to quickly retrieve it, right? You just get to the block that that particular data is sitting in and retrieve it, basically. So it is usually stored in a block format, not in a file format. It is stored in a block format. So there's no need for directory like in the file storage type, where you have to know the paths that that file is stored in. This one is stored in block format. It doesn't need a directory. Second characteristics is that it is single EC2 instance attachment, right? So you can only attach one EBS to one EC2 instance. You can only attach one EBS to one EC2 instance. It's just like your hard drive, right? You cannot have two hard drive inside one computer. You can only connect one hard drive to one computer, basically, that is inside your laptop. It's only one hard drive that is going to be there, not two. Right. So just like that, your EC2 instance can only or your you can only attach one EBS to one EC2 instance. You cannot attach it to multiple EC2 instance. Although there's a caveat now, right? And we're going to see that in the following slides, right? There's something that you can now call EBS multi-attach, right? But we are going to get to that. But by default, you can only attach one EBS to one EC2 instance. So you cannot have one hard disk and then attach it to different computer. Hope I'm making sense. Hope we're getting it. You cannot have one hard disk and then attach it to different computer. It has to be one to one, basically. If I'm attaching this hard disk to my laptop now, I cannot attach it again to another laptop except I'm detaching it or removing it from this current computer that I am using and attaching it to another computer, right? So that's one of the characteristics. Another characteristic that I forgot to add here is that it is detachable. So you can detach an EBS from a particular instance and attach it to another instance. You can attach it, you can say, okay, when I created this particular EBS, right, I attach it to this particular computer or particular instance, EC2 instance, but I think I want to delete that instance. So I'm creating a new instance, but I still want the same data that was on that instance to be on this new one, right? So I can just detach that EBS from that old instance and then attach it to the new instance that I am creating. So a characteristics of EBS is that you can always attach and detach it from an EC2 instance. Also, the another characteristic is that it is persistent storage. So when you say persistent storage, it means the storage stays. It's, say for example, if you started that or you launched an EC2 instance now and you stopped the instance. When you stop the instance, whatever data that is in your EBS, right, it still remains. Even if you terminate an instance, your EBS still remain. It's just like if you destroy, if your, like I was saying, that if your laptop should crash, right, your hard disk is still going to be there. The only thing that will happen to your hard disk, right, is if you destroy the hard disk itself, and then the data will be gone. But if the hard disk is intact, nothing has happened to it, you find out that you can still get the data of all the applications on your laptop, right? Again, once you connect that hard disk to another computer. So characteristics of EBS is that it is persistent storage, which means that the data would remain even if the EC2 instance that it was attached to is stopped or it is terminated. That data would still remain, except you go and delete the EBS volume itself. Hope we're getting me so far. Can we indicate if you can still hear me and you are you understand to this point that I have explained? Okay, all right. Okay, thank God. Okay, so let's move on then. So now, components of EBS. What are the components of EBS? So one of the component of EBS is volume. If you look at the previous slide, you find out that in the bracket it says unless the volume is deleted, right? So what is a volume? So a volume is the actual place, is what you call the actual storage unit of an EBS. So if you want to say, oh, I have attached an EBS to an instance now, right? EBS is the service, the volume is the resource. Just like you have your S3 service, right? And you have bucket. For EBS, it is called volume. For EBS, it is called a volume. So the volume is what is actually storing or housing the data that you are putting on it. It is what is going to be housing your application data and whatever data that you decide to save on the EBS, right? It is the volume that houses it. So it is the actual storage unit where your data is going to be stored. And there are two types of it, right? There's the SSD and there's the HDD. That's SSD is solid state drive, and then HDD is hard disk drive. Now these are two types of volume, and the difference between it, SSD is the new one, is the newly improved drive, right? While hard disk is the one that we used to use, and they both are still functioning and they both have different capacity. SSD is usually faster, it operates much more faster than an HDD. So if you have a laptop that the laptop is using an SSD kind of drive, right? You find out that when you are booting your system, it comes up faster than a laptop that is using HDD. And HDD would have a slow booting rate, right? That's because SSD usually is processes faster than an HDD. In the additional resources in this slide, when it is uploaded to LMS, you'll find the slide of additional resources. So I've put links that we can go and read up more on SSD, on HDD, and some other things are in those additional resources. So for now, all you need to know is that there are two different types of volume. You have SSD and you have HDD, right? And I'll still talk about them, later. Another component of the EBS is snapshots rather, sorry, snapshots. So what is your snapshot? It is an incremental backup. So I've said your volume is attached to an EC2 instance, right? So the volume is what is storing the data. Now, for you to back up the data that is stored inside the volume, those backups are called snapshots. And they are called snapshots because it's like you are taking a picture of what is there. It's like taking a picture of the data that is sitting in that volume at that time, and you're putting it somewhere else. So that in case, if for any reason something happens to the EBS, maybe you mistakenly deleted it or something, you can always go and retrieve that data from the backup, which is your snapshot. So one thing to note here is that what your snapshot are incremental. And what does it mean to be incremental? It means that it will only capture the change data. In the slide that will follow, I will explain what that means, what incremental backup means. There's a picture I'll use to explain to us. So for now, just know that snapshots is a component of EBS, and what snapshots means is they are incremental backups of your volume. They are incremental backup of your volume. So whenever you hear snapshots in cloud computing, just know that they are backups of your volume. It's like taking a picture of the current state of the data in your volume and saving it somewhere else. Now, those snapshots are usually saved in Amazon S3. So if you create a snapshot of EBS volume now, where AWS will save that snapshot is in S3, right? So S3, because it's an object storage system, it can take any type of thing. It can take any type of data, basically. So that's where, and because it doesn't have a restriction, remember we mentioned on Monday that S3 can take any amount of data, right? So it's is the best fitting storage type to save your backups as well. So that's another component of EBS. The third component of EBS is encryption. I know Mr. Moses was one that also taught us on encryption, right? And if you can still remember what encryption is, it's basically coding your message, right? So for EBS, you can have encryption at rest and in transit. What at rest and in transit basically means is that when you are transferring your data, either you are moving data to your volume, right? It is encrypted. So no hacker can see the community or what's your data, what that thing you have put in the volume, right? Or you want to put in the volume. No hacker can see it because it has been encrypted. So in transit means at the time when you are trying to transfer the data from one point to the other, either you are trying to upload data to the volume from your laptop or something, right? At the moment when it is moving, that is in transit, your data will be encrypted. And after it has gotten to its destination in the volume itself, while it is sitting down inside the volume, while your data is sitting inside the volume, it is also encrypted. So one of the components of EBS is encryption. Now remember I mentioned multi-attach the other time, right? So multi-attach is what allows EBS to be able to attach to different EC2 instances. Now, remember at the beginning when we talked about the characteristics, we said EBS can only be attached to one single instance per time, just like your hard disk, right? It can only be attached to one um, computer at a time. Now, what multi-attach does is that if you have enabled a multi-attach or you provision a multi-attach volume, EBS volume, what will happen is that you can use that one hard disk to connect to multiple instances, multiple computer. But the restriction is that those instances must be within the same availability zone. Those instances must be within the same availability zone. So if you have, maybe you've created an instance in availability zone 1, and you have another instance in an availability zone 2, you now created an EBS in maybe availability zone 1, right? That EBS will only be able to connect to whatever instances you have in availability zone 1. It cannot be connected to the instance in availability zone 2. It does not have that capacity, even if it is multi-attached. It's just like you have 4 systems here, and you have your hard disk, right, that you have brought out. It only probably has one port, USB port, right? So primarily it can only attach to one computer at a time. But if you now have maybe you bought an hard disk, right, that has multiple ports, so it means you can connect more than one computer to that hard disk at the same time. But the restriction would be that all of those computer has to be close together, right? They have to be within that same area. So you cannot have one computer with you in the parlor and another one inside the another person's compound, and you want to connect the hard disk to it. It won't be possible. But if all the laptops are with you, maybe in your sitting room, you can easily connect. You just look for a cord to connect. That's what multi-attach does, right? So when you provision a multi-attached volume, you are able to connect, you can break that barrier of EBS being connected to just one EC2 instance. So you'll be able to connect it to more than one EC2 instance, but those instances must be within the same availability zone. You cannot connect an EBS to instances that are in different availability zone. Hope we've gotten that part. Can do we get that part? No. So Tejiri, I'm just saying your question, right? So EBS is usually for applications, application data, right? Most like for your server data. So since EC2 is your cloud server, is your virtual server, so EBS is what you attach to it. So you can't attach EBS to something else, basically. It's attached to your instances. Attached to your instances. So can we move on? Money Magnet is saying no. What's your what don't you understand, Money Magnet? Okay, so while Money Magnet is probably typing their question or a question, let's move on. So two things I've explained with this picture that you're seeing on my screen, right, is EBS volume types. So remember at the beginning, I said we have two volume types. We have the SSD and the HDD. We have SSD and HDD. Now each of those volume types are also now broken down further. So under SSD, remember SSD is your solid state drive. Under SSD, you have a general purpose SSD. General purpose SSD usually provide a balance, right? I've also put a resource there. I want us to actually read, right? So that's why I'm not putting all this explanation here. So I've put a resource that will explain what each of these volume types mean, right? The general purpose, the provisioned IOPS. I've also put a resource that will explain what IOPS is and what throughput is. But just on the surface, right, throughput is basically the movement of your data, right? Movement of data in and out, right? It's what controls it, how fast data is moving. That is what throughput is, right? So depending on what the customer needs is going to determine what kind of volume you are going to be attaching to their EC2 instance. So it is important that you go and read up on those things, because it will be intentionally added to our quiz, because I need to know that you are actually reading just beyond this the presentation that we do during the class. You need to read extra. So that's why I've put those resources there. So please read up on it. And if you have questions after you have read and you don't still understand, you can chat me up personally or chat Mr. Moses up. So for you to know this evening, just know that under SSD you have two types. Under HDD you have two types. So under SSD you have GP2. GP2 is your general purpose SSD, and then you have IO1. IO1 is your provisioned IOPS, right? IO1 is your provisioned IOPS. Then under HDD, you have ST1 and SC1. ST1 means throughput optimized, right? Basically, it means that this one is optimized. It's much more optimized for a fast moving of data, right? Then you have SC1, which is your cold HDD. Cold HDD means that is for data that you don't need to access very, very fast, like that, right? You don't need to access it very fast, or you don't need, it's something that it can be there. You might not even access it in a long while, right? So that's what the code HDD is for. So if you have a customer that says, oh, I want to start up an instance or launch an instance, right? What kind of EBS volume you would attach to that instance will be dependent on what that customer actually needs, right? When you read up on all of these types, you would be able to understand what I'm saying, right? So please go and read up on them. All right. So on this right hand side, I talked about EBS snapshots, right? And I said snapshot is your backup, is the backup of your volume. It's like taking a picture. So remember, I also said that snapshots are incremental. So what do I mean by incremental? If on the first day that you attach this EBS volume to an EC2 instance, on the very first day, it has the data that it got in the volume were just maybe the name of the application, who created the application, what are the dependencies or the libraries that the application will be running on. Those are the only data that is there, right? So it's going to save, when you take a snapshot of that volume at that time, it will take all of the things that were there, because that's the first time you are going to be taking the snapshot. So your first snapshot is usually taking everything that is in the volume, right? So on day one, that snapshot will back up all the data that is in your volume, everything that I've just spoken about. Now on day two, right, the second day after you have attached this EBS, maybe now I have now added to the information that is in the EBS volume. Maybe I've added a kind of a database information, right? Maybe I've launched a SQL database on my instance, because you can also launch a SQL or deploy or host a database on an EC2 instance, right? So maybe I've deployed a SQL server on my EC2 instance. So it has gotten more information. So on that second day, when you take a snapshot of this EBS volume, it's not going to now have take all of the data again. It's not going to take a snapshot of all of the data. It will only take a snapshot of that one that you just added on the second day. It will only take a snapshot of the one you just added on the second day. So remember, this was all that was there on day one. It took a snapshot of it. On day two, I only added SQL Server. So it will just go and add that SQL Server to the list. It's not now going to go and take another snapshot of this one, and then you now have day one, day one, day one, day one, and then day two. No. What it's going to do is it will only take a snapshot of what has changed in that volume. What is the new information? Or maybe you deleted something. Only the changed data would be taken on subsequent days. So on day two, right, I only installed my SQL Server. Maybe I only installed SQL Server. There was no information on it at that moment. So on this day two, it only had information of the SQL Server that I updated, the type of server it is, the version of the server, and all of those things. So it has saved it. Now on day three, I have now gotten data, students' data of Lita computing class, right? I've put it on the SQL Server. So it's not going to, on day three now, when it's backing up, the snapshot is not going to include um the name of the SQL Server and the version of the SQL Server anymore, because that is already there. So it's now going to add. So it's just going to add. It will just be adding on top of it. Whatever has changed is what is going to be adding. right? So it is incremental. And why is this important to know? Is that if it doesn't do it that like that, your storage cost is going to be very high. If it means that every time is taking a snapshot, is taking everything, right? Say for example now, on this day, the amount of data that was here was just 2 gig, right? Now I added information for SQL on the third day, right? Maybe that information for SQL was just about 1 gig, right? Let's just assume 1 gig. So I now have 3 gig. On the first day, I've already taken this 2 gig. I've taken a picture of it. On the second day, I don't need to take this picture of this 2 gig again. I will only take the picture of the one that has changed, which was just 1 gig, right? So what I'll be billed for now will be just the 1 gig that I have taken on that particular day, not 3 gig, because this one they've already captured it on the first day, right? This one is the only one that I am adding to it. On the third day now, I've added just this. Let's say these two now were about 4 gig. So instead of having 2 gig on day one, 1 gig on day two, 4 gig on day three, all of those things, right? What the backup will do is that it will just take only this four and add it. So it's, you see how it's layering it. It will just be adding it to it. It should be taking it from here and just adding it to it. Take from here, add to it. Whatever has changed, only the things that has changed. It is only on the first day, like the very first time you are taking a snapshot ever, that is when it will take all of the data. If for example you've not been doing backup, right, you've not been taking snapshots, and all these one, two, three, right, we're already inside here. All of these one, two, three were already inside here, right? And you want to take the snapshot of this volume for the very, very first time. All of this will be in your day one. All of this would be in your day one. So on the very first snapshot that you are taking, it will capture all the data that is inside the EBS volume. But after that first time, what it will now start doing, it will now just be adding data that you have changed. So it will come here and check, okay, EBS volume, what's changed today. If on day two you did not add any data, it will not take any snapshots, right? It's not going to take any snapshots. Do we understand that? Do we understand that? Yes. Okay. All right. So thank you. Let's move on. Okay. So just like everything, right, in life, there's advantage and there's disadvantages, right? So what are the pros and cons of Elastic Block Store? What are the pros and cons? So Elastic Block Store is an high performance storage type, right? It is suitable for application that requires fast disk I/O. Say it's just like when you have your hard disk in your system, right, and you need a data. It's faster for you to retrieve that data from your hard disk because it is there. It is attached to your computer, right? It is not something that you have to go and start looking for. So if I need maybe the information of the students, or the information of the SQL server that I deployed or hosted on my EC2 instance, I will quickly get it. Why? Because that information is sitting in the hard disk that is attached to my system. So whenever your the applications or your EC2 instance require high performance, right? EBS is the best. That is why, in short, that is why EBS is the one that is usually attached to an EC2 instance. It's not like you cannot attach other stuffs to an EC2 instance. You can attach an EFS to an EC2 instance. You can attach an S3 to an EC2 instance. But the best for your application data is usually your EBS. Is usually your EBS, right? Because it's going to give you, especially if the applications that you have require very fast performance or high performance, very fast I/O. I/O is your throughput, right? Your input and your output. It requires fast movement of data in and out, right? So EBS is best for it. So that's one of the advantages of it, high performance. Number two is that it is durable and it is available. So you can always replicate the data in it, right? EBS, again, if you delete your EC2 instance by mistake or by error, or the EC2 instance crashed, right? Your data is already saved in the EBS. You can just detach that EBS and go and attach it to another new instance that you created, and you have all the things that you add there what coming up. So it is durable. It's not something that just goes, except you now go and delete it yourself, right? And it is available with you can always make it it is replicated within the same availability zone, not within different availability zone, right? So of course your costing will be reduced because you're not doing it in two different availability zone. Then backup and recovery, right? You can take a snapshot of your volume at a particular time. Maybe the very first time you want to take your snapshot is after I have already installed my application on the instance. You can take your snapshot at that time. That is what it means by the I think when Mr. Moses is teaching us tomorrow on backups and disaster recovery and all of those things, we'll be talking about RPO and RTO, right? Recovery point objective and recovery time objective, right? Those things will explain what I mean by point in time. So it's like at this particular time is when I'm taking a picture of this volume. So if I take a picture of the volume, yeah, that's your snapshots now, right? I'm using pictures that we can relate to it. So please don't call it picture. It's called snapshots. Right. So if I take a snapshot of my EBS volume in the morning, right, and and it is backed up. No, my snapshot is my backup, right? And it is backed up. If for any reason anything happens to that EBS, maybe I mistakenly deleted it in the evening. Meanwhile, I've already added more information to that volume in the afternoon, but I did not take a snapshot of it. Remember, it is incremental. So if I did not take a snapshot of it, at the time I'm going back to my backup, the only data that I will have there was the one that I put there in the morning, because that was the time that I took that snapshot, right? But if I had taken a picture of it in the morning, I took a picture of it in the afternoon, right? If I mistakenly deleted the EBS volume in the evening and I go to my backup, right, the snapshot I've taken, I'm going to see all the data that I've put there in the morning and in the afternoon. Why? Because I took them at that point when all those data were there. Hope you get. So snapshots, they will provide a point in time. So if your company probably put a data on EBS now and then something happened, it crashed, right? Maybe yesterday was the last time that you took a snapshot. By the time you want to reattach, maybe you are taking from the snapshot now to create a new EBS volume. It's where it stopped backing up, right? The data that was on that volume as at yesterday when you took that snapshot is what is going to be in the backup. So that's what it means by point in time recovery option. So again, you can always go back to say, oh, maybe yesterday what they put there was wrong, somebody mistakenly did it. So you took a snapshot day before yesterday. I can say, okay, the data I want to recover is from day before yesterday. So I'll just go to the snapshots that was taken day before yesterday, and I can retrieve the data that was on it, basically. So that's what point in time recovery means. Integration, of course, like I said, it's the go-to storage service for an EC2 instance. So they integrate seamlessly. In short, if you've noticed when we're launching an EC2 instance, one of the options you need to click, right, is your storage disk. And that storage disk is usually your EBS. So what are the cons of an EBS? Number one is the limitation that it can only be attached to what a single instance, except you are using a multi-attach. And even with the multi-attach, it can only be attached to an instance or multiple instances that are within the same availability zone. So that is a um, a disadvantage of the EBS, right? You cannot attach it to multiple instances except you enable multi-attach, and that multi-attach also has a caveat of those instances you want to do multi-attach with has to be in the same availability zone. Number two, scalability. Now, because the way EBS works is that you have to provision the amount of data you think you would need, right? So at the point of attaching it to your instance, right? You have to determine, okay, maybe what I think this instance, the things I'll put on this instance, right? They'll probably require about 80 gig of data. So you have to put the amount, the size you want at the point of creating the EBS, whether it is 80 gig or just 2 gig that you want, or 3 gig, right? You have to put it. Now, if you now find out that that 80 gig is too small, you have to manually go back and go and increase it. You have to manually go back and increase it, or add another EBS. So you can only attach one EBS to one EC2 instance, but one EC2 instance can have more than one hard disk or one EBS. Hope that did not confuse us. One EBS can be attached to only one EC2 instance, but an EC2 instance can have more than one EBS attached to it. So I can have only one, I can only attach one hard disk, right, to my computer, but my computer has more ports. So I can attach another hard disk on the left hand side, attach another hard disk on the right hand side, right? So that's basically what I'm trying to say. Hope we get that. Then for cost. So cost, you are paying for provisioned capacity. So at the point of launching or provisioning your EBS, right, you are stating the amount of storage you want. Let's say you have checked that, oh, this instance that I'm launching, all the application I want to put on it, the amount of data they will need is about 80 gig, right? So you have provisioned 80 gig of data, but then maybe you are not using up to 20 gig. It's already there. AWS will charge you for the 80 gig. AWS is not going to charge you for just the 20 gig that is there. So you are paying for what you provision. Whether you are using it fully or you are not using it fully, you are going to pay for the capacity that you have provisioned. If you provisioned only 5 gig, you are going to pay for 5 gig. Whether you are using only 1 gig out of it does not concern AWS. So those are some of the advantages of EBS. Okay, so before I explain EFS, hope we are clear on EBS. Someone says the screen is not sharp. Is that for everyone? Or is my screen clear to everyone, or it's blurry for everyone? Okay, it's sharp. Okay, so that means Debbie, it's probably your network that is making the screen not sharp on your end. Okay, so we're good to go to moving to EFS now, right? Thank you everyone. All right, thank you very much, Chidera, Ayola, and Tejuri, and Patience. Thank you. Okay, um so let's move to EFS, right? Excuse me. So again, the naming has given it away. If I ask now that the EFS service, right, the Elastic File System service, is under what type of storage? At the beginning I said there's block storage, there's file storage, and there's object storage. So what type of storage do we think the EFS falls under? The name has already given it away, right? So, but let's see if we're following. What type of storage does the EFS fall under? Do you think the EFS falls under? Yeah, file storage. Yeah, exactly. So the name has given it away. So file storage. Oh, it's past 8 already. Okay, let's quickly take our break for attendance. Can we do that now? At 30. File storage. That's good. Thank you everyone. Ediri, should we take a attendance break now, or I should still continue? Okay, all right. So we can still continue for now. The attendance link is coming up. So once the attendance link comes up, I'll take a pause and then we can fill our attendance form, basically. All right, so thank you, everyone. Yes, the EFS, like the name implies, is a file storage, is under the file storage type, right? So what is EFS? The full meaning of EFS is elastic file system. Remember, the full meaning of EBS is elastic block system. So EFS is elastic file system. Sorry, for EBS rather is elastic block storage, while EFS is elastic file system. So EFS is a fully managed file storage service, right, that allows multiple systems to access the same files and folder. Remember I said a file storage type, right? Your data is stored in files. You can have folders, you can have subfolders, so you have directory, basically. So an EFS system is like your file manager on your laptop, right? Where you have different category. You have the desktop, you have the download, you have the documents, you have pictures, right? So you can have those, each of those are like folders, right? And inside those folders, say for example, if I have a picture in my on my system, right, and I save that picture in a folder called liter, right, and that liter is in a folder or a location called pictures. For me to be able to get to that picture that I saved there, right? I'll first of all go and open pictures on my file manager, right? And then go and open the folder called liter. And then that's where I will now see my image that I uploaded there. So there's a path to it, basically. So that's the same way the file system works, the same attribute. Now, what is the use case for an EFS? It is for sharing data between multiple server and for big data analytics. So unlike elastic block store that you can only attach one EBS, you can an EBS can only be attached to one EC2 instance, right? Unlike that case, an EFS can be attached to multiple EC2 instances. An EFS can be attached to multiple instances. An EFS can be attached to multiple server, basically, right? So it's like a shared drive that is used in the office, right, where multiple people can access the same document. Let me use the example of maybe you have a wardrobe, right? Now in that wardrobe you have different sections. You have maybe a section for the father, you have a section of the wardrobe for the mother, you have a section of the wardrobe for children, right? Now all the members of the family, if they want to pick their clothes, right, they have to go to that wardrobe. So which means that that wardrobe is being shared by every member of the family, right? But inside that wardrobe there are different sections, like folders, there are different folders. So when me I need my own clothes, right, I go to section where I keep my clothes. When this person, the children needs clothes, they will go to the section where the children's clothes are. When the father needs clothes, he'll go to the section where the father's clothes are. But that wardrobe is made accessible to everybody. So I am sharing it, my husband is sharing it, the children are sharing it, basically, right? So that's how the EFS is. So multiple instances can share one EFS, right? They can is basically called a file sharing system, right? So a typical example or a real world scenario for an EFS is, say in your office now, you have a file system. That file system probably houses data for employee data, customer data. You have everything in folders there. You have a folder called customer data, you have a folder called employee data, you have a folder called sales, right? You have a folder called what else? Products, right? Now, say for example, HR needs to access that file. They need to access what are they calling it now, employee data, right? Maybe the data team, they need to tell management how much they are selling, which product is selling the most, so they need to have access to the product data and the sales data, right? but all of those things are inside one file. So it means that that file will have to be in a drive, in quotes, right, where all of them can access, and everybody will now go to the one that concern them. So let's take that HR is one server, the data team is another server, right? Maybe the finance team is another server, all of them sharing that file. So EFS can be connected to more than one EC2 instance and across different availability zone. Unlike EBS, that okay, they said okay, there's a multi-attach option, right? But there's a restriction of you cannot attach an EBS to instances that are in different availability zone. For the EFS, you can attach to instances that are in different availability zone, right? So EFS is a regional service. As long as those instances are within the same region. Remember, you have different availability zone inside a region, right? So as long as those instances are within the same region, you can always connect to it. But for an EBS, even if those instances are within the same region, as long as they are in different availability zone, you cannot connect an EBS to instances in a different availability zone, right? So what are the characteristics of an EFS? Number one is that it is a file level storage. It is a file level storage. Okay, so so sorry. I think I've missed the message since I could not see this message. All right, please let's go for our attendance break now, then we'll come back to this. I'm so sorry, Edere. All right, so please let's go for our attendance break now. Apologies, apologies. The attendance link would be in the description button. I think I did a screenshot and sent to our Telegram group just in case you're using your phone and you don't know how to get to that point, right? So you can just check the screenshot I sent on Monday to the Telegram group if that would help. But it's in the description box underneath the name of the YouTube page where you have Ladies in Tech Africa, Cloud Computing and AW. You see 69 watching or the number of people watching, blah blah blah. And then you see somewhere where you can click more. Click on that more for those using laptop, right? To take you to you see more text there. So just look for the take your attendance and click that link basically. So I think that should be easy for us. All right, Grace, thank you. Now, is it just Grace that has finished filling the attendance? Please signify if you are done. Done. All right. Thank you. So we had about 70 people. I want to believe the people that are not here now are those that have gone to fill the form. So let's just give about 2 more minutes. I think that should be fine. All right. Thank you for everyone that has filled their attendance. Thank you. And also, let me use this opportunity to also say thank you to everyone that attempted the quiz. It's a good thing to attempt it, even if you don't get everything, right? Even if you don't get everything, it will stick to you, to stick to your head to see. Do we get to see the correction of the quiz for anyone you miss? Do you see the correction? Oh, I did page. Sorry about that. Okay. All right. So it's a good thing that you see the corrections of the one that you missed, so that that way you learn from it, and next time when you see that question, of course, you'll be able to answer it easily. Yes, the quiz is no longer there. It's closed on Monday. Closed on Monday. If you didn't take it, please be on the lookout for. There's an assignment currently on the LBS. I hope I've seen that too. Okay, so one more minute. Once it is 8:15, we'll get back to class. Okay, I've been told to please elongate the time. All right, so let's give it 3 more minutes. 3 more minutes. Okay, so there's a video that was uploaded to the S3 bucket. Just hearing that there's a video uploaded to the S3 bucket. So to the LMS rather, a video on S3 buckets, right? That Mr. Moses did for us on Monday. That's been uploaded to our LMS. So you can also check that out. Please and please, not you can, you should check that out, please. You should check that out. All right. So 2 more minutes, Mr. Ederi, 2 more minutes. By 8:17 would start. All right. Please and please take these things seriously. By the end of this week, we should be getting our credentials to the AWS environment, right? So I want to believe everyone, at least you did one of the quiz, either that of upper week or that of last week. Please make sure that you did one, at least one, because that's where I can, myself and Mr. Moses can get your details to create your AWS credentials. Is there anyone that did not do the um any of the quiz? You've not done any of the quiz at all. Can't find the assignment. At Ediri. Okay. I know I've been told that it has been uploaded already to our LMS. Not on any quiz. Ah, even now why? You've been attending class. How come? Those of us that have not done any of the quiz. Ah, please, our TAs, please help us with a guide to how they can access the assignment that is on the LMS. So that would be like a redeeming grace for those that have not done any of the quiz at all. Oh, okay, Levina. But you did that of the upper week, Abi, Levina. Angela, don't be scared about the percentage. Just attempt the quiz. Don't worry, we're not kicking anybody out. We're not kicking anybody out. We're all here to learn, right? And there has to be that understanding that all of us would not pick it up at the same pace. So grace is available. Okay, so it's 8:18. I think we can get back to class now. I think we can get back to class. So I've been told that for the assignments, please check the files. Go to your files. You will see that it is tagged assignment. So the assignment is not something serious. It's not like your quiz. It's basically you have links to some resources, you go and read up on those resources, and then you answer the questions that follow. Even attending this class already gives you um, insights to some of the answers of those questions, basically. Okay, so let's get back. Let's get back to class. Okay, Levina, no problem. It's fine. Just look out for the assignment and please do that. Thank you. All right, so getting back into our EFS discussion, I think the assignment is still open up until Friday, I believe. I think Friday we might elongate it or extend it till Saturday probably. So it should still be available for you to do. So let's get back. So characteristics of EFS. Can we still see my screen, please? Can you confirm you can all still see my screen? Yes, okay. All right, no problem. Thank you very much. Okay, so characteristics of file storage. Number one, which is the obvious, is that data is stored and accessed as files and directory basically. So directory is your path. Like, how do I get to this particular document or this particular thing that I've put in this file, right? So do I have to go through desktop? From desktop, I'll open a folder called Lita, and then from Lita, I will now see the file, right? So that part, if you find out, if you go to your system now and you want to, you click on any document, you can, when you right click on it, you will see something that says copy as part. And if you paste that part in maybe your office Microsoft Word, it will show you desktop. Let's assume the file is in your desktop, right? To show you desktop slash the name of the folder slash the name of the file. So that's your directory basically. That's your directory. So characteristics of file of EFS is that it is a file level storage. Your data is stored and accessed as files and directories. Number two is that in contrast to EBS, this one has multiple EC2 instance access. So you can connect one EFS to more than one EC2 instance at the same time. At the same time, you can connect one EFS to more than one EC2 instance at the same time. Number three, also in contrast to the EBS that you have to go and manually scale, right? For EFS, it will automatically scale down or up depending on the amount of data that is there. So for EFS, when you want to provision an EFS, right, you don't have to set the amount of data. It's not like EBS that you say, oh, I think I would need 80 gig. No, it's similar to S3 that you just be putting your file there. It will keep on enlarging to accommodate the amount of data that you have in it, right? So if today you have only 2 gig, tomorrow is 10 gig data you want to put, it will automatically enlarge to take your 10 gig basically. So there's automatic scaling for EFS, unlike the EBS that you have to go and manually go and scale up or scale down. What are the components of EFS? Component of EFS. Number one is the storage class. So EFS is similar to S3 in the sense that it also has storage classes that are similar to S3 storage class. Remember when Mr. Moses was teaching us on Monday, we said storage class, we have the EFS standard, we have EFS, I say EFS, S3 standard, S3 infrequent access, right? S3 glacier. So the same thing applies for EFS, but it's, in this case, it is named EFS standard. So EFS standard is your basic, is the default storage class, right? And it is the one that you would use when you need to deliver very fast. You are going to be accessing that data like every time, right? You'll be accessing the data every time. It's something that you access um frequently. That's the word. Frequently is the word, right? So if you know that that data will be accessed frequently, and you know that you need to have that data like sharp sharp, EFS standard is the storage class to use. While EFS infrequent access, or EFSIA for short, right, is at a lower cost, and it is much more it is recommended for data that you're not going to be accessing every time. I remember somebody asked that question last week as to how do you know the data that you'll not be accessing every time. It's just you have to watch it. Say for example, on your laptop, right, you have some documents that are there that it was the first day you opened it, that's the last day you have opened it. It has just been sitting on your laptop and it is occupying space there, right? So, but you don't want to delete it because you probably feel like, oh, I might need this data one day, right? Say someone was telling me about how he used to save transaction history on his phone, and he doesn't want to delete it because he never can tell when he will need it. But those kind of a thing now, if for example he's using an EFS, if it is in the standard, it will just be consuming money because standard storage is the highest cost, right? Incurs the highest cost out of all the storage classes, right? So standard incurs the highest cost. So if that is transaction history that is storing is in standard um storage class, it will just be incurring a lot of cost. So you can move it to maybe infrequent assets. You can say, okay, this particular transaction history, I've had it for like 2 months or 3 months and I've not opened it again. So instead of it being cost at the same price as the ones that I'm accessing every time, right? I'll just move it to infrequent access, basically. Then maybe the ones that I've not accessed in 2 years or 1 year at all, right? I'll move that one to archive. So it is still there, but I'm not going to be spending so much on it. AWS will not be billing me for standard price because each of those storage class have different pricing, right? So EFS archive is the last one. It's just like your S3 Glacier, right? They are for archive storage. Like I said, maybe data that you don't access, you've not touched, you've not opened in like 1 year, you've not opened it in 2 years. There's no need for them to be on standard. There's no even need for them to be in infrequent access. Move them to archive. They will still be there. So whenever you need it, you can always restore it back, right? And move it back to either infrequent access or standard. So archive is like the lowest cost basically, and it is recommended for data that you've not accessed or you only access very, 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 very rare occasions, very few times, basically. Now, on that storage class, just like in S3, like you have your life cycle policies, right? You also have life cycle management for EFS. So that is where you put a rule, right? You write a policy to say, okay, help me monitor this my file, right? If there are documents or objects or files that I have not accessed in 2 months, that I have not come to open, I've not touched them at all in 2 months, move them to infrequent access. If in 3 months or in 6 months, depending on whatever it is you want to set it at, I've not still opened it, then move that to archive. So you can use lifecycle management to automatically help you move files to different storage class depending on the rule that you set on that lifecycle policy, basically. So what's the other component of EFS is that it can scale. It is elastic. Remember I mentioned also before that it scales automatically. Unlike for EBS that you have to go and manually add to it, it scales automatically. And the throughput is how fast. Remember I said it was how fast data is moving in and out, right? Throughput also scales. So if for example as somebody is putting data, somebody is requesting for data, somebody is putting data, somebody is requesting for data, right? How fast those things are going on is like your throughput. So if at a point it's only one person that is accessing this data, right? Not just storing it now, you have already stored the data is there, but for accessing it, only one person is accessing this data at a time, right? The throughput is going to be small, right? Because not so many people. But at the point maybe you have 50 people, one person is trying to get customer data, another person is trying to get HR employee data, somebody else is trying to get sales data, all from the same file system, right? Is going to increase the throughput capacity so that it can be fast. It will not be so slow, basically. Then also, just like the EBS, it also supports encryption both at rest and in transit. I believe we'll still remember what encryption at rest and in transit means. Okay, so pros and cons of the elastic file system. What's the pros and cons, right? the advantage number one is scalability. Again, unlike EBS, this one will automatically scale. If you remove a file today, maybe you remove a 1 gig worth of file, it will automatically shrink to say, okay, this is the amount of storage that you need. If you increase, maybe you added more files, you added 20 gig, it will automatically expand to accept whatever amount of data that you need, right? Then another advantage is shared access. Shared access in the sense that more than one EC2 instance can use it per time. So you have an application that is on this EC2 instance, you have another application on another EC2 instance in another availability zone, you have another application sitting down somewhere on another EC2 instance. But instead of having to start provisioning different EFS, right? You can just create one file system and then attach that one file system to all the EC2 instance, as long as they are within the same region. As long as they are within the same region. Okay, so hope we have gotten that. So to where I've stopped now, we understand so far. So far, are we getting it? Are we lost at any point? Let's just pause on going to go and check the LMS for now. Let's just be here in the class. Let's be here in the class for now first. Okay. So can I move on? Do we get to the points that I've explained it to? Okay, thank you very much, Miriam. All right, so moving on, my mouse cursor doesn't want to move. So another advantage is elastic pricing, right? So unlike EBS, that you only pay, you pay for what you have provisioned, whether you are using it fully or not, does not concern. If you say, oh, I think it's 80 gig that this instance would need, and you provision 80 gig, and at the end of the month it's only 20 gig you use, AWS will not bill you for 80 gig, and they will not bill you for 20 gig rather, they will bill you for the entire 80 gig. So for EBS, you are paying for your provisioned storage, what you provision. But for EFS, you pay for the amount of data that you have. Just like your S3, you pay for the amount of data that you have, right? So if it is only 20 gig of data that you have at the end of the month in your file system, it is only 20 gig you'll be charged for. If by the next month it increases to 30 gig, you only be charged for 30 gig. If you deleted some files from it and then it has now reduced to just 15 gig of data that you have in your file system, at the end of that month you only be billed 15 for 15 gig of data basically. So there's elastic pricing depending on the amount of data that you have there. Of course, high availability. Remember I said you can attach it to instances across multiple availability zones. So if you are in a region that has maybe about 4 availability zone, right? You can Your EFS will be replicated across those 4 availability zones. So if you have an instance sitting in any of those availability zone, they can always connect to that file system. Now, what's the cons of EFS, the disadvantages? Number one is that there's performance variability in terms of latency. So latency is how fast you get data, right? Or you get access to something. Unlike your EBS, it is an hard disk that is attached to your system. So when it needs to get something, it can quickly just, go and pick it from there. But for EFS, it is not like that. It will take a longer time, and longer time can be maybe just few seconds longer, right? It doesn't mean that, oh, it's going to take like 1 hour, but in computing world, every microsecond counts. So latency is usually higher compared to EBS, right? Then it is actually more expensive than EBS. EFS is way more expensive. It's about times 10 of EBS price. And why would you think it is more expensive? I mean, you can attach it to more than one instance at the same time. So unlike EBS, that if you have another instance in another availability, so you have to go and provision another, it's guesswork, right? You provision another one. If you have another one in another AC, you provision. So if you have 3 different instances in three different availability zone, right? For EBS, you have to be provisioning. You provision 80 gig for this one, provision another 80 gig EBS for this one, provision another 80 gig EBS for this one. But for EFS, you can provision just one and then attach it to all the three instances in all the three availability zones. So it is actually much more expensive than your EPS. And the complexity of it, to set up and to manage it, is much more complex, right? So I don't know if, I think I forgot to add it here, right? One of the components of if EFS is what you call mount target. So your mount target is like an address of the EC2 instance, right? That's uh of where your EC2 instance is sitting, that is going to connect to, basically. So for every of those availability zone, you have to create a mount target. So your EFS will be communicating through that mount. It's called mount, MOUNT, mount target, basically. So if you have 10 different instances across, you have to manage each of those mount targets. And networking can get, the more it is, right, the more complex it becomes. So it can become complex quickly. Setting it up and managing it can become quite complex. So that's a disadvantage. So do we get it up onto this point? All right. Olushola almost saying attendance is in the description. That's been posted. Has been, we're taking a break for it before now. It's in the description box of this YouTube channel. Please just find the description box. Click on more. You will see take your attendance. Click on the link that is there, and you will get to the attendance form. All right. Thank you for those that say we can move on and you're getting it. So this is an example of how file system work, right? So a VPC, I think when we do networking, have we done networking? I don't think we've done networking, right? When we do networking, we're going to explain more, dive deeper into VPC and all of these things, right? So VPC is the one you create in a region. A VPC is region based. So when you're creating a VPC, it's called your virtual private cloud. So I can create a VPC to say, okay, this application and this application and this application are going to be in this VPC, and create another VPC in another region, right? So VPC is usually in a region, right? So in this region now, there are three availability zone. There's US West 2A, there's US West 2B, there's US West 2C. So US West is the region, right? US West is the region. And in that region, there's 2A, there's 2B, there's 2C. Now, if you notice, subnet is where your instances will be sitting within the VPC. So subnets are usually sitting inside the availability zone. VPC is sitting in the region, right? Availability zone is within the region, right? Now your subnet is within that availability zone. So every subnet you create, you have to choose this availability zone you want that subnet to be in. Then your EC2 instances you want to provision will be sitting inside a subnet. You can put anything in your subnet. You can put a database, you can put EC2 instance, whatever it is that you want to provision can be in any subnet, right? In any availability zone. So in this picture now, right, we have this EC2 instance in availability zone 2A. We have a subnet here, but there's no EC2 instance here, right? We have a availability zone 2C. We have one EC2 instance. Now, remember I said mount target is one of the components of EFS, right? So you provision a mount target here. This is the address of a mount target, the IP address of the mount target. You provision another mount target in this availability zone. You provision another mount target in this availability zone. So what will happen is whatever resources is here, right, will be communicating to this file system through this mount target. So if this one wants to get file from here now, it will go through this mount target. So if you don't have a mount target, there's no way that this EC2 instance will be able to communicate with the EFS. So mount target is a very critical component of the EFS, and I don't know how I forgot to add it to our slide. Maybe before we put it on ELMS, right? I'm going to include it there so we don't forget. So mount target is important. So you can see that this one EFS system that is provisioned is feeding all of this availability zone. Even this one that does not have an EC2 instance, you have a mount target there. So if I create an EC2 instance here tomorrow, automatically it can connect to this file system because there's already a mount target there. Do we get that? Okay, all right, thank you very much. So let's do a side-by-side comparison of EFS and EBS. Let's do a side-by-side comparison. So depending on the feature, based on the type of storage, right? EBS is a block level type of storage. EBS is like a block level type of storage, while EFS is a file level type of storage. So the difference is that for type of storage, EBS is block, EFS is file, right? On access, based on access, right? EBS can only be accessed by one EC2 instance at a time. So you can only attach one EBS, or rather, one EBS can only be attached to one EC2 instance per time. So two EC2 instance cannot connect to one EBS. Two EC2 instance cannot connect to one EBS. While for EFS, more than one EC2 instance can connect to one EFS at the same time. More than one EC2 instance can connect to one EFS at the same time. On scalability, for EBS, right, it is a fixed size. You would put a fixed size at the point of provisioning your EBS. And if you need to scale up, you have to go and manually go and reduce it. So when you want to provision an EBS, if you say it's 80 gig that you think you will need, you have to provision that 80 gig. Whether you are using it, you are going to use finish or not, it does not concern anybody. Right? You have to provision that 80 gig. Whether it's 20 gig, you need to provision that 20 gig. If for any reason you need to increase, you have to manually go and increase or decrease. While for your EFS, because you are not doing a provisioning at the beginning, right, it will only it will automatically scale depending on the amount of data that you have stored. If you only have 20 gig of data, it will enlarge to accommodate 20 gig of data. If it's only 10 gig, it will decrease or shrink to accommodate just 10 gig of data. So for EFS, it is scaling automatically. For EBS, it scales manually. You have to go and do it yourself. For performance, right? EBS is high performance for single instance applications. So instance applications that are sitting on just one instance, right? EBS offers very high performance for them. While for EFS is offering scalable performance for multiple instances, right? So remember when I was explaining the components, then I talked about scaling of the throughput. So since it is connected to more than one instance, if it needs to enlarge, right, depending on people that are accessing, depending on how fast data needs to be moving, if there are plenty of people trying to access data at the same time, right, it will enlarge the throughput to accommodate for all of those instances at the same time. So for EBS, high performance for just one instance. For EFS, scalable performance for multiple instances. Then for use cases, for EBS, your database, your boot volume, your single instance applications that only need one instance. There are some applications that you will need more than two instances to join together for them to work, right? There are applications like that. But for single instance app, EBS is better because remember it can only connect to one EC2 instance at a time, except you're using the multi-attach. And the multi-attach, remember there's a clause that all of those instances has to be within the same availability zone. So your databases, your boot volume, your applications, EBS is the right or the recommended storage type to use. While for web serving, for content management, for shared directory, right? Things that involve multiple people needing access to the same thing, right? EFS is better suited for it. Now, for cost structure, For EBS, you are paying for provisioned capacity, even if you are not using it. You are paying for provisioned capacity even if you are not using it. While for EFS, you are paying for only the amount of storage that you are using. If you're only using 2 gig, you are paying for 2 gig. If you're only using 5 gig, you are paying for 5 gig. So there's elastic pricing. Your pricing is dependent on the amount of data that you have stored in EFS. But for EBS, it is dependent on what you have provisioned at the beginning of it. So you are paying for provisioned capacity, while for EFS, you are paying for storage capacity. Do we get it up to this point? Understood. All right. Thank you very much. Someone said the diagram was not clear. Ah, okay. I should come again on the diagram. Um, this diagram, oh no, happy. This diagram. Okay. All right. So I was saying that in the AWS structure, right? This is an example of an architecture, right? So in the AWS structure, everything you want to do has to be within a VPC. Everything you want to have to do has to be within a VPC. Now, when you are provisioning your VPC, you have to choose the region in which that VPC will be. For example, this VPC was created in US West 2 region. US West 2 is probably I think is either North Virginia, I can't remember, or Ohio. I can't remember which one, right? So is sitting in the region. Now, within the region, if you're here at the beginning when we started, when we talked about the global infrastructure of AWS, tell that we have region, we have availability zones. So availability zones are within a region. It basically means that if AWS has a region in the US, maybe they have a region in North Virginia, right? Within that North Virginia, they now have different availability zones. Maybe they have one in this county, they have another data center in this county. So each of those data center in different parts of that region are called availability zone. So in this diagram now, we have this EC2 instance is sitting in availability zone US West 2A. This subnet now is in US West 2B. This one is in US West 2C, right? Now, this EFS, remember at the beginning, I also mentioned that EFS is a regional service. So when you are provisioning your EFS, you don't need to choose the availability zone to be sitting. For EBS, it will be in a particular availability zone, right? But for EFS, it will be in the region that your VPC was created, basically. So I've created an EFS here. Now, I want my EC2 instance that is here to get whatever file that it needs from this file system. I want this one that is here to get data from this file system. I've not yet put an EC2 instance here, but I can decide to put an EC2 instance here or put whatever application I want to put in this place, right? Nothing is there. But how will this EC2 instance get this data that is inside here? It needs a mount target. So mount target is like an address, right? Is an IP address. So the EC2 instance will connect to this mount target. The mount target connects to the EFS. So that's why you have mount targets in each of the availability zones. So if you look at the lines here, you find out that this one in this availability zone is connecting to this EFS. This one in this availability zone is connecting to this EFS. This one here is also connecting to this EFS, all at the same time. That is what EBS cannot do. EBS, it has to be connected to only one instance. Only one instance. Remember, there's more than one instance here now. For EBS, it's only one instance it can connect to, except you are using a multi-attach. And that multi-attach will only mean that all the instances you want it to connect to with multi-attach for EBS now has to be within one availability zone. They cannot be in different availability zone like this. So EFS can connect to multiple instances within different availability zone. Hope that is clear now. Is that clear now? All right. So Levina is saying okay, I'll answer this question at the question time. Let's move fast, right? Please Tia, please help me note uh the questions. So I'll take them. So let's move quickly. All right. So cost example for EBS and EFS. Remember I said EFS is much more expensive. So let's give a scenario. So the scenario for this is that you have provisioned a 100 gig of general purpose SSD. Remember, we talked about volume type and we said volume type will have SSD and we have HDD. And under SSD, we have general purpose, right? And we have provisioned IOPS. When you read the resources that I've attached, right, you understand it more. So we have provisioned 100 gig of data. Now, the cost of the way you are charged, right, for EBS is per gig per month. Now, because you have already provisioned 100 gig, per gig that you are being charged is 0.08 per gig per month. So which means that at the end of the month, maybe you provision that EBS at the beginning of September. So at the end of September, AWS will be sending you a bill of $8. Why? $0.08 multiplied by 100 gig is $8, right? Now, this is irrespective of whether the data you have inside this 100 gig is up to 100 gig or not. Whether it is up to 100 gig, it does not concern AWS. They are going to bill you for this 100 gig. Now, if you look at the EFS, you have moved data to EFS and the amount of that data is 100 gig. All of the data, you are not provisioning, right? All the data you have moved is 100 gig in the EFS standard storage. Now, the cost of standard storage is 0.30. Can you see the difference between the amount? This one is 0.08 per gig. This one is 0.03. This one is 0.3 rather. 0.30 per gig. So for 100 gig of data stored in EFS, at the end of the month, EFS is going to AWS send you a bill of $30. While if it is EBS will send you a bill of what? $8. Now, where does the difference comes, right? If, for example, I now remove 20 gig of data, I now have only 80 gig in my standard storage. What will happen? AWS will now bill me for only 80 gig rather than 100 gig. But you cannot do that for EBS. So even though it is more expensive, you can always scale in and scale out depending on your need. Again, you can use the lifecycle management that I mentioned as part of the component of EFS right then, that you can on the storage classes. You can use it to automatically move your data to different storage class. If required access is much more cheaper than standard storage, archive is much more cheaper than infrequent access and standard storage. So you can use it to also regulate your cost, basically. Okay, so let's look at some scenarios for use case for all of this, whether EBS or EFS. So scenario one is that you have a single application server, right? Now this application server needs a very fast dedicated storage. Again, EBS is a dedicated storage, right? So what would you recommend if you're a cloud engineer? What you will recommend for that customer that wants to put just a single server, is putting just a single server, that's a single EC2 instance, right? And that EC2 instance needs a very fast dedicated storage for the database that he wants to put on that server. What would you recommend? EBS. And why? Because EBS will give it a high performance storage for a single EC2 instance. Now, scenario two, you have a web application. Now, this application that you have is not on just one EC2 instance. It's not just on one server. It is on multiple servers. So it is on multiple EC2 instances. And those multiple EC2 instances need to access the same content. Maybe it is images or it is file or it is document. All of those instances, right, need to access the same content. What storage type are you going to recommend to them? It's going to be the EFS. Why? Because EFS will allow all of the instances to access it at the same time. you can have multiple access to one EFS at the same time. So you see the difference between these two is that this one is just a single EC2 instance. This application here is sitting on multiple EC2 instance, and all of those EC2 instance, they need to access content at the same time, right? So EFS is best suited for them. Our last scenario is data analytics, right? So you have multiple instances that are processing the same data set. Maybe you have an application to be processing a data set that contains maybe customer data, employee data, and all the like. So you have one EC2 instance that is processing maybe customer data. You have one EC2 instance that is processing employee data, but all those data are inside one particular file, and you need all of those analytics instances, right, to access those data at the same time. What would you use? Again, is the EFS, because EFS will allow them to have access at the same time, multiple instances having access at the same time. All right. So this is the slide 19. This is additional resources. When you get the slide, you can just click on these links to take you to pages where you can read more on some of these things that I've spoken about. Okay, so let's take questions now. I have 6 more minutes, so take questions and then we'll do our knowledge check. Thank you. I like that you are answering. Well done. She Texas cloud engineers in the making. Well done. Very good job. Okay. So any questions? I think I saw a question earlier. Yes, so Levina was asking that as a cloud engineer freelancer, which one of the storage is better used between EBS and EFS? Again, the type of storage is dependent on what your clients need. That's why I gave the example of those use cases, right? If your client wants to put just one application on one instance, right? And that application needs to access data, fast, 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 then EBS is much more suited for them. But if the person needs if the person's application is on multiple EC2 instance, of course, and those EC2 instance need to access the same information, and that information is in a has to be in one place. All of them has to be accessing the same kind of information at the same time, right? So what you recommend in that case is going to be EFS. So what you are recommending to your client is dependent on the kind of application or the kind of use case that they have, basically. Hope that is understood, Levina. Then Fitainment Hub asks that does EBS require mount target as well? No, EBS does not require a mount target, majorly because it does not need to be connected to multiple instances, right? It's connecting to just one. It is attached. It is called attached. It is attached to just one EC2 instance, so it doesn't need a mount target. A mount target is needed for EFS because it's what is showing it where am I giving the how am I going to give this one the information, basically. So the mount target is standing as an interface between the file system and the EC2 instance. So if the EC2 instance that is in availability zone A, right, only needs data for maybe customer now, right, is going to go through that mount target to go and get it, so that wrong information will not go to the wrong instance, basically. So that's why mount target is needed for EFS, because it's connecting to multiple instances at the same time. So I know how you saying that. Why is the name GP2 and GP1? Why do we have GP? So those are under the what are you calling that, volume types, right? We had a volume type that is called GP1 and GP2. Well, go and read the resources I gave you. I'm not going to say the answer because it's probably part of the questions that I put there. So go and read. That's one of the way I will know that you have read the resources I gave to you. So go and read up on it. Number two question says the file that is stored in different availability zone, will it be charged based on the number of files that you store or the same price? So you're not storing the files in different availability zone. It's like the example of the wardrobe that I gave, right? The wardrobe is containing all the files, whether the wardrobe is containing all the clothes for everybody in the family, whether for mommy or for daddy or for children. No, the wardrobe contains all of it. So I'm only being charged for all the clothes that is inside that wardrobe, right? I'm only being charged for whether my child is coming to come and pick from that wardrobe. I'm not going to go and bill my child separately, right? I'm only going to bill for all the clothes that is inside that one wardrobe. So you're not putting the files in different AZ. You're putting the file in one region. So every instance that needs to take data from that file will come and take their data. So AWS will bill you on the data that is inside that one file system that you have provisioned. Whether it is 10 EC2 instance that is going to connect to it does not concern AWS, right? If it is, they are only billing you based on the amount of data that you have inside that one file system, basically. Hope that is understood. Honor Niyilolawa. Does that mean that different AZ from the same region cannot access EFS without the mount target? Yes, they would not be able to access the files without the mount target. So a mount target is a very, very, very important, is what is pointing to the instance, right? Is what is giving direction to the file system to say this is where you are taking this data to, this is where you are taking this data to, right? So that there's no mix up of data, basically, of information. So a mount target is important. All right, so is that all the questions? Can I ask my own questions now? Ooh, it's 9 o'clock already. So let's use 3 minutes to quickly answer our do our knowledge check, basically. Ah, please give us few minutes to, don't pursue us. We're sorry for taking time. All right, so let's go to our knowledge check. So question one. Can we all still see my screen, please? Major difference between EFS and EBS. I mentioned it earlier on. Let's quickly take our questions so that our admins will not kick us out this night. So this first question says that you want to store data in an object storage service. I intentionally added this question. I wanted to see if we were paying attention. So which service is best for this type of storage? An object storage service. A, Amazon Managed Blockchain. B, Amazon Elastic File System. C, Amazon Block Store. D, Amazon Simple Storage Service. What's our answer? D. Thank you very much. That's good. So yes, S3 is an object storage service. Correct. Clapping for you people. All right. So yes, our answer is Amazon S3. It's the object storage service. So question two says which statements are true about Amazon EBS volume and Amazon EFS file system. So which one is true? Which of these statements is true? A, EBS volume store data within a single availability zone, while Amazon file system store data across multiple availability zone. B, EBS volume store data across multiple availability zone, while EFS stores data within a single availability zone. C, EBS volume and EFS volume both store their data within a single availability zone. And D says EBS volume and EFS file system both store their data across multiple availability zone. A. Okay. All right. So I think I've gotten enough answer. So our answer is A. Yes, we've overflogged it this night, right? We've said it that EBS will only store data within what, a single availability zone, and that's why it cannot connect to instances that are outside the availability zone that is a sitting. But EFS, because it is a regional service, and within each region you have multiple availability zone, so it can store data across multiple availability zone. So A is the right answer. Question 3. Oh no, I went to duplicate this question. So this is gone. Let's go to question 4. So in terms of pricing, question 4, in terms of pricing, what is a key difference between EBS and EFS? A, EBS charges for the data that you store and it will automatically scale. B, EBS charges based on provisioned capacity even if you don't use all of it. C, EFS will charge based on provisioned storage, not the actual storage. D, EFS requires that you pay for a fixed amount of storage regardless of your use. This is very tricky, so please read it very well before you choose your answer. Now I'm seeing multiple answer. I know that this question was going to cause quanta. Again, what is the key difference in terms of pricing? Number one, is it that EBS will charge you for data that you store and it will automatically scale? Or number two, EBS will charge you for provisioned capacity even if you don't use all of it, right? Or EFS will charge you for provisioned capacity, not the actual storage. Or EFS will require that you pay for a fixed amount of storage regardless of your use. Let me give 3 more seconds. Someone says B and C. You cannot choose two. Choose one. It's not multiple answer. Choose one. Okay. All right. So let me show the answer now, right? So the answer is actually B. The answer is B. Remember, I know the naming convention can be a bit confusing. EBS is elastic block store, right? Elastic block store, you will pay for the data that you have provisioned, which means that at the point that you are provisioning your EBS, you say, oh, it's 80 gig I think that I would need. You put the 80 gig, right? Whether or not you use the 80 gig, that's I've been giving that example since. Whether or not you use the 80 gig does not concern AWS. They will bill you for 80 gig because that is what you have provisioned. But for EFS, you are not provisioning data. You are not provisioning storage, right? So it is dependent on the actual storage usage, depending on what you are using. For EFS, if it is only 20 gig that you put there, it's only 20 gig they will charge you for. If it is 50 gig you put there, it's only 50 gig they will charge you for. So for EBS, you are paying for provisioned capacity. What it is that you think that you are going to use. If you put 80 gig, that's what they will put bill you for, whether or not you are using it. For EFS, you are going to be billed for your actual storage usage, depending on the amount of data that you have. So B is the right answer. Do we still have one more question? Yes, the last question. So which statement is true about EBS snapshots? Remember snapshots? I thought we talked about snapshots today. So which of these statements is correct about EBS snapshots? Number one is that snapshot are full backups that consume the same space as the original data. B, snapshot captures the entire EBS volume regardless of what has changed. C, snapshot are incremental, meaning that they will only store changes that you made since the last snapshot. D, snapshots are automatically shared between multiple EC2 instances. This should be easy for us. Furizola says she chop fish eye. Don't worry, it's part of it. That's why we're learning. All right, so I said this should be easy. So let's check what our answer is. Yes, so we mentioned that snapshot hours are incremental. It is the changes that were made on the former on the volume as at the last time you took a snapshot. That's what is going to save again. So every day or for every time you're taking a snapshot, it will only to keep increasing it based on the changes that you've made. So snapshot are incremental. So yes, our right answer is C. So we've come to the end of the class today. Thank you very much for spending extra 7 minutes with me on the call. Thank you for paying attention. Thank you for answering and participating. Thank you for putting in the efforts and staying in the class. God bless us. All right. Have a lovely night rest, everyone. Have a beautiful, beautiful night rest. Bye, everyone. Thank you, too.